Hi dear students, let us continue the sets. In a previous video, we have just taken that types of the set, definition of the set, and intervals like that. Different type of the set already was just taken. Based on that different type of the set, here what universal set or sets would you like to propose for each of the followings? Here already know that universal set. What is a universal set? There are some sets under consideration. All the sets are the subset of the largest set. Sets, several sets are there. All those several sets are subset of the largest set. That largest set is said to be a universal set. Already know that. Now we need to write the universal set. What universal set or sets? Only the single set or more than one set. Set or sets would you like to propose for each of the followings? In a following two sets they are given. First set is the set of all the right angled triangles. Set of all the right angled triangles, and second one is the set of all the isosceles triangles. For these two sets, which one is a universal set would you like to propose? That is the question. I just named the first set as A. This set is denoted as A. This set is denoted as a B. Set A. What is the set A consists? Set of all the right angled triangles in a two-dimensional plane. Whatever the right angled triangles are there, right angled triangles already know that Pythagoras theorem, hypotenuse square is equal to remaining side length square, sum of squares of the remaining side length. Okay, so right angle triangle, and the set of all the isosceles triangle. Set of all the isosceles. What is meant by isosceles triangle? A triangle having two sides are in equal length and their opposite angles are also equal. Two sides and two angles are equal. Such as triangle which is called as a isosceles triangle. Right angle triangle and isosceles triangle. So set A is represents the set of all the right angle triangles. Whatever the right angle triangles are there, all those right angle triangles. Isosceles triangle is nothing but two sides and two angles are equal. Set A and the set B is that. So these two sets are a subset of a single set. That set is denoted by U. What is the universal set? What is the universal set we can propose? So this universal set contains the set B as well as the set A. This set contains the right angle triangles as well as the isosceles triangle. What we can write? Can I write this set of all the triangles? Set of all the triangles in a plane. Whatever the type of the triangles are there, all type of triangles are considered universal set. So that is nothing but this set, universal set, contains isosceles triangle as well as right angle triangle. Therefore, the required universal set is set of all the triangles. This is how we have to write. This is a 1 marks question. Now, second one is next question. Write the following intervals. Write the following intervals in terms. Write the following intervals into set builder. Into set builder. They are given intervals. Those intervals we need to write into set builder. First one is -3, 0. Open interval -3, 0. This is the open interval. Already know that interval, closed interval, open interval. Closed interval means end points are included. This we can write in a set builder form. How? X such that A is less than or equal to X is less than or equal to B. This is said to be a closed interval. And open interval means A comma B. This we can write X such that A is less than X is less than B. This is said to be a interval and this is said to be a set. How many elements are present in this interval? Infinite number of elements. In this set, infinite number of intervals are subset of the real numbers. Here closed interval, open interval, and semi-closed open interval, semi-open closed interval. Remaining two types. Already know that. Here they given an interval. This interval we need to write into set builder form. Write the set builder form. How to write the set builder form? X such that x will be how to choose from where to where, from minus 3 to 0, minus 3 to 0. Minus 3 and 0 are included or not included? Are not included. Why? Because open interval is there. Here strictly inequality is that minus 3 and 0 are not included. For example, here it is a positive infinity, negative infinity. Here it is a minus 4, minus 3, minus 2, minus 1, 0, 1, 2, like that. Real numbers are there. Here minus 3 to 0, minus 3 to 0 is there. Minus 3 and 0 are included or not included? Are not included. These values are not included. In between the minus 3 to 0, whatever the real numbers are there, all the real. This is not required, just for your understanding purpose. I am just writing the real number line. Minus 3 and 0 are not included. In between, all the values are included. For example, minus 2.9. Where is the minus 2.9? Very closer to the minus included, but minus and minus 2.999 is included. Minus 2.999999 is included, but not exactly the minus 3. Here, negative side of the 0, exactly 0 is not included. Minus 0.000001 is included, but not exactly 0. Approximately we can write it as a 0, but not exactly 0. This is included, but this is not included. This is the meaning of the open interval. I just given this real number line just for your understanding purpose. In the examination, it is sufficient to mention this one. If we need, just mention this one. Okay. Now the second interval. I have written what is that? Interval into the set builder form. Now the next interval is closed interval 6, 12. Closed interval 6, 12. Write in the set builder form. How to write the set builder form? There are some x values. How to choose the x value? X value we are going to choose from 6 to 12. 6 is included. Yes, closed interval is there included. 6 is less than or equal to x is less than or equal to 12. So this is the value. Next, similarly, third one. Very simple. Closed interval endpoints are equal. It is whenever they are given a closed interval, write the slack inequality, and whenever they are given a open interval, write the strictly inequality. It is a strictly inequality and it is a slack inequality. Next one. 6, minus 10. Semi-open closed interval 6, minus 10. This is 6, 10. Semi-open closed interval 6, 10. How do I write this one? This we can write x such that what are the values of x can we take? 6 is not included, so that strictly inequality x is less than 10 is included, so that slack inequality. That's right. Similarly, fourth one is minus 1, 8. Semi-closed open interval. Semi-closed open interval minus 1, 8. What can write this one? X such that minus 1 is less than or equal to x is less than 8. This is how we have to write the interval into the set. Okay. Now the next point is operations on the set. So this is till so far we are just studying that what is meant by set, representation of the sets, and the types of the set. Next one is operations on the set. Operations on the set. There particularly 3 operations are there. One is union of the sets. Second one is intersection of the sets, and third one is difference of the sets is there. Third one is difference of the 2 sets or 3 sets, whatever. So at this or present academic year or your academic year, only the two operations they have kept. Union of the sets, intersection of the sets they are kept. Difference of the sets has been removed for this academic year. Okay. Now I am not going to discuss the difference of the sets. Now I am just going to discuss the union of two sets and intersection of the sets. Okay. First one is union of the sets. Now we need to come to know that what is meant by union of the set. For discussing union of the set, I just consider the two non-empty sets. Let two non-empty sets. Two non-empty sets. A and B. Two non-empty sets. A and B. A and B are the two non-empty sets. What are the non-empty sets? A set which consists at least one element in it. Non-empty sets A and B are there. Now, union of these two sets is denoted by A union B. Union of these two sets is denoted by A union B. A U B. This symbol is represented as the union of the set. Read as A union B. What is the A union B? A union B, which is also a set which consists. This is also a set. Another set we can call it as a C. A and B are the two non-empty set. Union of our two set is denoted by union B. Again, after taking the union, we will get another set. For example, suppose 2 and 3 are the two numbers are there. Operations on the number, you know that. What are the operations we can do on the numbers? Addition we can do, subtraction, multiplication, division. These are the four operations we can do. After doing any one of the operations with these two numbers, the resultant is a single number. If we add these two numbers, we will get a 5. Subtracted -1, multiplied 6, divided by 2 by 3, another number will get 0.6 will get it. Is that clear? After doing the operation, there is a unique number will get it. Two pair of numbers are there. After doing the mathematics operation, any one of the operation will get the respective number, unique number. In the same manner, two sets are there, A and B. After doing some operation, what is that operation I am just doing? Union I am just doing. Union is represented as a union B. Resultant set is also a set denoted by a C. How we have to do the operation? How we have to do the operation? Means all the elements of the set A and all the elements of the set B. Common elements are going to write only once. Common elements is to write once. Is to take only once. What is the union of the two set? Union of the two set is nothing but A and B are the two set. Union is denoted by A and B. Resultant is also a set. That set contains all the elements of the set A, all the elements of the set B. Common element is going to write only once. This is how we have to take the union of the two sets. Is that clear? Particularly example. Suppose the set A is equal to 1 or else 1, 3, 5, 7, 8, 9 is there. Similarly, the set B contains 2, 3, 4, 6 is the two set. A and B are the two non-empty set. I would like to take the union of these two sets. What is the union of the two set? Is denoted by A union B. Read as A union B. Write A to B. Okay. Is equal to. It is also a set. How to write? What is the elements we have to write here in this set? A union B. All the elements of A, all the elements of B, and common element is going to write only once. So elements of A 1, 3, 5, 7, 8, 9. Elements of A is written. Elements of B. What are the elements of B? Is there? 2 is there. Okay. 3 already we have just written. Written elements going to write only once. 4 is not written. Write the 4. 6 written the 6. No, 6 is not. Okay. 6 is not there in the first set. Right. This is said to be a union B. What is a union B? A and B are the two non-empty set. Union of two set is nothing but all the elements of the set A, all the elements of the set B. A repeated or a common element is going to write only once, and A union B is denoted by A to B. Read as A union B. After taking the operation union, resultant is also a set. That set is denoted by C. So, or else A union B. This is the required A union. Very clear? Very simple thing. Right? All the set of A, all the elements of A, all the elements of B, common element, we will write only once. That's all. Now, the next thing is properties of unions. Properties of union of a sets. Properties of union of a set. What are the properties are there? So while adding the two numbers, A and B are the two numbers are there. Addition, subtraction, multiplication, division. There are some properties are there. For example, A plus B is the same as the B plus A. What is this law? Commutative law. Similarly, associative law, law of identity, like that, the several identities are there. In the same manner, here also some properties are there. What are the properties? Suppose, for discussing this property, I just consider the A, B and C are the any three non-empty sets. Let A, B, C are the any three non-empty sets. That first one is commutative law. First one is the commutative law. What is the commutative law? I just write it. Commutative law. What is that? A and B are the two non-empty sets. A union B is equal to B union A. A union B is same as the B union A. Either you can take the commutative union of two sets in this manner, A union B, or else take the B union A, will get the same answer, nothing to worry. And apart from that, while writing the elements of the set, order is immaterial. Already know that order is immaterial. Whatever the order, you can write the elements, nothing to worry. And repeated elements are going to write only once. And equality of the two sets. When we need to say that two sets are equal, all the elements of set A and B of the two sets is said to be equal. When these two sets are equal, each and every element must be same on both the sets. Is that clear? For these two sets, each and every element must be same. Then only we can say that these two sets are equal. Equivalent set. What is the equivalent set? Cardinality is equal. N of A is equal to N of B. N of A is equal to N of B is said to be equivalent set, and A is equal to B is nothing but every element must be equal. Same element. Okay. Make the difference. Very important one. Now here commutative law. A union B is same as the B union. Either do the operation in this manner or do the operation in this manner. Doesn't matter. Next one is 3 set A union B union C is equal to A union B union C. What is this property? A union B union C. Either do in this manner or else A union B union C. This property is said to be associative law. This property is named as associative law. In the real number, addition, multiplication satisfy the associative law. Already know that. Third one is law of identity. A union null is equal to A union null. A set. A is a one set. Union of null set. What is a null set? Which do not contain any elements in it. A union null is equal to how much? A will get it. No. Next, this is said to be that law of identity. Law of identity. I just wrote this one. I just mentioned whatever the points you just need. Next, fourth one. A union universal set. Law of inverse. What is that? Or law of U. What is the law of U? Law of U is nothing but law of universal set. A union U. What is the set A? Union of universal set. All the elements of A, all the elements of universal set. Can I say that it is the universal set? Universal set is nothing but which consists of all the elements in it. Whatever the elements, well-defined objects are there, all the elements are contained in it. Next, fifth one, we can say that A union A. What is the A union A? A union A is equal to A itself. This is said to be that idempotent law. This is the idempotent law. The names are not required, but you just remember these things, or else you can remember the names. Nothing to worry. Commutative law, associative law, law of identity. A union null set is equal to A only. Law of U is nothing but A union universal set is a universal set, and A union A is A only. That is said to be a idempotent law. Very simple. So we can satisfy all these properties taking the any element. This is true for all the or any set. Okay, this is the operation of union of two sets. Now, operation of intersection of the two sets. Second one is intersection of the two sets. What is the intersection of the two sets? Again the same thing. Let A and B are the two non-empty sets. A and B are the two non-empty sets. That means it consists at least one element in it. Okay, A and B are the two non-empty sets. Intersection of the two sets is denoted by A intersection B. A intersection B, right? U reverse ladder, we reverse image, we need to write A whereas A intersection B. After taking the intersection, once again we get the set only. That set we can denote it as a C. Doesn't matter, or else A intersection B. A intersection B is going to take all the elements of A and elements of B. Elements of the set A and the elements of the set B. Elements of A as well as elements of set B. There is a common element. Whatever the elements of A and B are there, elements of A and elements of B. Here, common elements we have to write. Elements of A and elements of B. We have to write common elements only. Common elements. Or else we can write common elements of A and the B. Common elements of the set A and the set B. Here, A intersections B contains an element which is present in the set A as well as present in the set B. What is the A intersection B? A intersection B is a element which is contains an element which is present in the set A as well as present in the set B. That means common elements are going to lie in this operation. Are you clear? For example, suppose the set A is equal to A, B, C, D, E, Z, and the set B contains A, E, I, O, U. First set contains the first 5 letters of an English alphabet, and second set contains the vowels of an English alphabet. Now I would like to write that A intersection B. What is the A intersection B? This is a set consists of elements of common elements of the set A and the set B. Common elements of set A and the set B. What are the common elements are there? A is there, write the element A. Next, B is here in the set A, but it is not present in the set B. Next, C is not present in both of the sets. D is not present. E is present in both of the sets. So write the E. And next, I is present in only B set. O is present in only B, and U is also present in only B. So what is the A intersection B? A intersection B is equal to the elements are A and E only. Now what is the A intersection B? A intersection B is a set consists of common elements of the both the set, or common elements of the given two non-empty set. Common elements of the given two non-empty set. A intersection B is equal to A comma E for these two particular examples. In the same manner, as we have taken the properties of the union of the two sets, in the same manner, properties of intersection of the two sets. Properties of intersection of the two sets or three sets, intersection of the sets. Here also I just consider the three non-empty set. Let A, B, C are the any three non-empty set. First one is A intersection B is the same as the B intersection A. A intersection B is same as the B intersection A. That means commutative lag is satisfied for the intersection of the two set. Intersection of the two set satisfy the commutative lag. Similarly, for the three set, that is A intersection B intersection C is equal to A intersection B intersection C. This is said to be that associative lag. Associative lag is satisfied for the intersection of the three sets. Next, to discuss the associative, we must have the three sets. Next, A intersection null. What is the A intersection null? A intersection null. Can I write it as a null set only? Yes, A intersection null. What is the common element between the set A and the set null? Null set is nothing but there is no element. A set is nothing but here also the null set subset, already know that. So there is common element between these two sets is null set. This is said to be that law of identity. This is said to be that law of identity. Similarly, law of U. A intersection U. What is the A intersection U? A is a non-empty set. U is a universal set. Universal set and a particular set A. What is the common element? That is the set A is the common element. This is the law of U. Law of U. Next, fifth one. You can write. What is the fifth one? Idempotent law. What is the idempotent law? A intersection A. What is the A intersection A? A set intersection of A set only. That is nothing but common elements between the A and A is nothing but A. This is said to be that idempotent law. This is the idempotent law. One more law is that I just write here. Sixth one. A intersection B union C. A intersection B union C. What is the A intersection B union C? Is A intersection B. A intersection B union A intersection C. A intersection B union C can be written as A intersection B union A intersection C. This is said to be a distributive law. This is said to be a distributive law. So these are the 6 properties of intersection of the two set, and these are the 5 properties of union of the two set or a three set. So very important properties you must remember. While we just taken these properties means while doing the operations of the 2 or 3 sets, whatever number of sets operation you are taking means either do in this manner or do the right hand side manner. Left hand side manner you can do it, or else right hand side manner we can do it. Whatever the manner, will get the same answer. That's why we have generated the properties of the operations of the set. So these are the mainly 2 operations: union of a two set, union of a sets, and intersection of the sets. One more operation is the difference of the set. For this academic year, that has been deleted. Anyway, now let's take some problems based on these operations on the sets. Yes, based on the operations on the set, let's take the problem in the exercise 1.4. I have not mentioned previously. I have not mentioned any exercise numbers because simple problems are there. Different model of the problem I have already solved. I'll explain in the definitions only. The remaining problems of the exercise, I just left to you people. If you have any doubts, just ask me in WhatsApp group. Now, here 4 sets are given. Set A. 3, 5, 7, 9 and the 11. Roster form of the set is given. B set is 7, 9, 11 and the 13. C set is 11, 13 and the 15 is that. And D set is 15 and the 17. 2 elements. Now we are required to find that A union B, A intersection C intersection D, and A intersection B union D, A intersection B intersection B union C. A union B intersection B union C. These 5 cases value we need to find. Okay, first one. What is the first one? A union B. You can write directly, or else if you need to just mention the sets. A set. What is that? 3, 5, 7, 9 and the 11. Union of B set. What is the B set? 7, 9, 11 and the 30. Already know the definition of a union of set. What is the definition of union of a set? Elements of the set A, elements of the set B. Common element is going to write only once. Right? Elements of the set A as well as elements of the set B. Common element going to write only once. Okay. What is that? 3 is that, 5, 7, 7 here also is that, here also is that, 9, 9 is that, here also is that, next 11, 11 is that, next in the set A, these are the elements, in the set B, 13 is that, write the 13, because I am just writing the union B, so A union B is equal to this one. You just no need to mention this step, directly you can write this one, nothing to worry. Okay, first value is this. Okay, very simple. Elements of the set A, elements of the set B, common element is going to write only once. Second case. What is the second case? Here, A intersection C intersection B is there. They are not mentioned. Simultaneously, which is not possible to take the intersection of the three set. For example, suppose 2 plus 3 minus 5 is there. 2 plus 3 minus 7 is there. Suppose. Is it possible to operate or else take it as a plus? Is it possible to add simultaneously 3? Simultaneously 3 number addition is not possible. First we have to add 2 plus 3 or 3 plus 7. Then only we can take that number after operation will get the some number, that number with the remaining number. Is that clear? Simultaneously, which is not possible to add 3 number, we can add simultaneously. At a time only the 2. Whatever the operation, mathematical operation, we can take it for the 2 number at a time. For 3 numbers simultaneously, which is not possible. This is said to be a associative. Either do in this manner or do in this manner. So they are not mentioned anything. Bracket they are not mentioned. So that either you can consider first 2 set, or else first we just consider the C and D, then take the operation with A, whatever. So which one is you like to do? Whatever. I just first of all do the A intersection D. First find the A intersection D. A intersection C, bracket, intersection D is there. Here I am just going to write the intersection. What is meant by intersection? Intersection of the two sets. Intersection of the two sets is nothing but common elements only. That element must be present in the set A as well as in the set C. Common element between the A and C. What is the common element between the A and C? 3 is not there, 5 is not there, 7 is not there, 9 is not there, 11 is there. 11. Here also 11, here also 11. A intersection C is 11. Intersection D set. What is the D set? D set is 15, 17. 15, 17. Now, intersection of these two sets. What is the common element between these two sets? There is no common elements. That is nothing but null set. This operation value is how much? Then we get a null set. Is that clear? The second one is over. Would you like to cross verify? Means you can do it. First of all, take the C and D. What we get if you take the C and D? C intersection D. C intersection D. Is there any common element? Yes. 15 is there. 15 is the single concept. C is over. A set. What is the A set? Intersection 15. A and this set. Is there any common element? There is no common element. We will get the null set. Is that clear? Either can do the what we did in the first order in this manner. A intersection C and intersection D, or else doing this manner we will get the set. Here only we just prove the associative law with taking the particular example. Associative law is satisfied for any set. Okay, on the operation intersection. Second case is over. Are you clear? Very simple. Next, third case. What is the third case? Here they only mentioned it, bracket, that is nothing but A intersection B union D. A intersection B union D. First I just write the set A. What is the set A? 3, 5, 7, 9 and the L1 intersection of. Now I am just going to write the B union D directly. Union is the union of two sets B and D. What is the union of B and D? All the elements of B and all the elements of D, common element is going to write only once. There is no common element. Write all the elements 7, 9, 11, 13, D element 15, comma 17. B union D is over. Now intersection of these two sets. What is the intersection? Common elements. 3 is not there, 5 is not there, 7 is there. 7, write the 7. Next 9 is there, write the 9. Next 11 is there, write the 11. Next there is no elements in a set A, so leave it. So this is the required A intersection B union D. Very simple. Next one is third case is over. Now come for the fourth case. What is the fourth case? A intersection B. A intersection B. Intersection B union C. Intersection B union C. As this side. First of all, I just write the A intersection B. What is the A intersection B? For A and B, common element. What is the common element for A and B? 7, 9, 11. Common elements for A and B is 7, 9 and the 11. Intersection as it is. B union C. B union C. B and C. All the elements of B, all the elements of C, common elements we will write only once. What are the elements? 7, 9, 11, 13 and the 15. This is the B union C. Now intersection of these two sets. What is the intersection of these two sets? That is 7 is there, 9 is there, 11 is there. That's all. This is our fourth value. A intersection B. Intersection B union C. Over. Next, fifth case. Fifth case, what is that? A union D intersection B union C. First I am just going to write the A union D. A and D. Union is that. What is that? 3, 5, 7, 9, 11, 15 and the 17. This is the A union D. Intersection. I put our space so that I am just writing below. Intersection. Intersection of B union C. B and C. What is the B and C? 7, 9, 11. B and C. B union C. 13 and 15. This is the B union C. Elements of B, elements of C. Common elements is going to write only once. Now, intersection of these two sets. What is the intersection of these two sets? Intersection means common element. What is the common element? 7, 7 is there. Next 9, 9 is there. 11 is there. Next 15 is there. Yes, 15 in both the sets. Yes, this is the required result. A union D intersection B union C. So this is how we have to do the intersection union of the two or more set. Okay. In the same order, we just solve the some few problems are there in the exercise. Solve it. The remaining problems and next thing we'll discuss in the next video. Okay. Thank you.